Today, the second day for the second Tropical Ocean and Marine Sciences International Symposium 2020, TOMSY 2020, organized by Institute of Oceanografi and Environment, INOS, University Malaysia, Terengganu. Before we start, here are some housekeeping announcements. All your mic is mute by default. However, if you have any questions during the webinar, you may utilize the Q&A panel on the right-hand side. Please direct your questions to everyone. Our presenter will respond to your questions at the end of this webinar. And also, there are some cool features in this platform that we will be using throughout the webinar to engage with you. So now look at your participant tab on the right. If you do not see the participant tab on your right panel, you may call it out by selecting the participant icon. The participant's icon is next to your mic icon at the bottom of the window. So at the bottom of the participant tab, you will find two icons, the raise hand and feedback icon. You may use all these icons throughout the session later. So ladies and gentlemen, please allow me to give a short introduction to our primary speaker for this session. Dr. Suhaimi Bin Suratman is a professor in chemical oceanography at Institute of Oceanography and Environment, INOS, University Malaysia, Terengganu. He obtained his bachelor honors in chemistry and master from the University of Malaya, and PhD specialized in chemical oceanography at University of East Anglia in UK. His research interests focus on the water quality studies, which include nutrients, metals, and organic pollutants, especially in the river system, estuary, and marine. His main research focus now is to understand the nutrient cycling in the marine waters of the southern South China Sea. Recently, Prof. Dr. Suratman is selected as the local collaborator with researchers from the University of East Anglia for a project related to microplastic pollution. Today, he received 22 research grants valued about Ringgit Malaysia of 4.72 million. He has presented and published many papers on the monitoring of environmental pollutants at various international, local journals and academic meetings. Professor Dr. Suratman is also one of the grant evaluators in UMP and the ministerial level. At the same time, he reviewed many manuscripts from Scopus or Web of Science journals, which including the Journal of Environmental Management and Assessment, International Journal of River Basin Management, and others. So ladies and gentlemen, without any further ado, we will kickstart our session today. So please join me to welcome Professor Dr. Suhaimi Bin Suratman from INOS UMP to present his research on assessing the nutrients variation in circuit wetlands in Malaysia. So, Professor, the floor is yours.
Okay. Thank you, Dr. Tan. Okay. Thank you for the brief introduction about me. So today I would like to have a presentation about the assessing the nutrient variation in circuit wetlands. Okay. I'm going to highlight a few important things about my study in this circuit wetland. Okay. This is my brief in terms of presentation. It's going to be about introduction, what is about water quality, what is about the nutrient, the objective, the method I use in my study in circuit wetland, result and discussion, some conclusion and some acknowledgement for this study. Just to give a brief idea about the water quality. So as you can see in the slide, it's about the condition of the water. What type of the condition? That means you can analyze for the chemical part, for example like nutrients, metal, pesticide, or you can analyze in terms of the physical. Yes, you see the one is salinity, temperature. The last one is going to be the biology, microorganism, phytoplankton. So basically, the condition of the water, is it suitable for some purpose? Okay, for example, is it for the drinking purpose? Is it for the safety of the human contact? Is it for the health of the ecosystem? Okay, so most of this three parameters, we have some in Malaysia, we have some sort of a standard for the Malaysian water quality. Okay. For example, when you want to see in terms of the condition of the water for the freshwater system, we have in Malaysia, we have the National Water Quality Standard. Okay. When you condition for the marine system, we have this Marine Water Quality Standard criteria and standard. Okay. For the purpose for the sewage, that means for the industry, in terms of the water quality, we have the Environmental Quality Act 1974, and for the drinking purpose, for Malaysia, we have the Drinking Water Quality Standard. So actually, in Malaysia, we have so many in terms of the water quality standard. But I give you just a brief idea about this 1, 2, 3, 4. It's based on what you want to use for the water quality standard. Is it for the fresh water? Is it for the marine or sewage or drinking purpose? This is fresh water. Just to highlight about the water quality standard for the Malaysia, this is NWQS. Okay, as you can see that one, we have the physical part. We have in terms of the microbiology down there. Okay, coliform. And in terms of the classes, this one like class 1, class 2A, 2B, and until class 5. But that one is based on the condition of the water. Okay, for the marine, since we are in the marine conference, this is the Malaysia Marine Water Quality Criteria and the Standard and the beneficial user. Okay, as you can see, we have for the temperature, the physical part, until we have the metal, and plus all the nutrients. Yeah. Okay, it is the biological part. Okay, some introduction about the nutrient. Basically, what is nutrient is all about, I can say, is a food. Food for the phytoplankton. Okay, when we have a food for the phytoplankton, okay, and we have a good light condition, that means we have a good in terms of the growth of the phytoplankton. Okay, there are so many types of nutrients. Okay, we have the organic and inorganic substance, and we have this nitrogen and phosphorus. As I put there N and P, we have this also the silicate. We also have a carbon. But for this introduction, for this presentation, I only focus for N and P only, because this is the main inorganic compound nutrient that be using by phytoplankton. So what happened now? When you put something in terms of nutrient high in the aquatic system, for the freshwater also, for the marine system also, what we are going to have is the eutrophication. That means a lot of growth of the phytoplankton. That's what we don't want to see in the marine, in the aquatic system. Okay. In terms of the sources of the nutrient, we have the natural and anthropogenic. Okay. Okay. This is what we don't want, nutrient pollution. Okay. So most of the nutrient now is coming from the anthropogenic, that means the human activity, such as agriculture, aquaculture, domestic, then industrial inputs. This is a basic idea. As I said before this, why do we don't want in terms of lot of nutrient? It's good to have a nutrient in aquatic, because that one, as I said before, this is a food for the phytoplankton grow. But when you put a lot, you can have this alga bloom. Okay. So when you have a lot in terms of the phytoplankton on the aquatic system, what happens now? Okay, when the phytoplankton dies, it's going to be sink at the bottom. So decomposition process will be happen. And for the decomposition process, what happens now? You are using oxygen. Okay, for the decomposition process. And you going to have in terms of less oxygen in the aquatic system. That we don't want in the aquatic system. Okay. Some, as you can see in the slide, decreased temperature and the light availability for the bottom water. This one I get from the internet from Dias and Salman 1910. Okay, as you can see in terms of eutrophic area, hypoxic area. Okay, as you can see, just a tiny thing, tiny. You see for the Malaysia here, nearby here, I think this is Klang River. Okay, because Klang River, as you know, that Klang River is a very huge city. River. That means we have a lot in terms of big cities. We have a lot in terms of industry. Okay, they dump everything to the river system. This is an example of the eutrophication. Okay. These are green things. Okay, nearby the coastal area. This one the algae. You can see at the estuarine also. You can see the green things. Okay, what happened now? I give example of the Baltic Sea. Okay, fish die. Okay. Yes. Talking about when I talk about this nutrient, when I talk about this in terms of the water quality, and I received a grant actually from the MOSTI to do a research study at the city wetland. So why it's so important about the city wetland, because this is the in this city wetland, it's a closed system lagoon. Okay, if just to bring back your this one, as you can see, this one I got from the Google Earth. This one is 2018. Okay, the Google, as you can see, we only have this all the closed system. We only have during that time. We only have a shallow in terms of channel in this site. It's only 50 meters. So, and this one for the city wetland, we have many ecosystem in this area, as I put there, estuarine, mangrove, wetland, lagoon, and we have a lot of in terms of the activity inside the lagoon all over here. Okay, for example, we have the aquaculture, we have this plantation. Okay, this one, okay, I can give after this, but the very brief idea, there are so many activities in the wetland, but with the closest ecosystem. Okay, this is the aquaculture, is the brackish aquaculture in the city wetland. A lot of fish culture around here. Okay, this is Pengkalan Gelap. Okay, we have for UMT, we have a small research station at city wetland just over here. Okay. This is palm oil plantation, very huge palm oil plantation, and everything they go through when the input of the water. Okay, they go through from the Brambat Lake and through the Uda River, and they go through this one. Okay. This is Blue Archipelago. This is a private company that doing plant culture for the for the export. Okay, this one they go into the Charok River, and then after that it goes to the still wetland over here. Okay, so this is the record that we have from the internet. Just to highlight this thing, okay, it's going. It is something that is increased in terms of the activity in the still wetland. As you can see, in 2009, for example, the cage culture is around 2007. Okay, then it increased to 2001. Okay, compared to 2008 is around 2000, and increased to 2007 in 2009. Okay, just to highlight the things, but it's going in terms of doing this brackish water culture and oyster farming is increasing in the wetland. This is some research paper, the scientific study that I collected from the scopers. Actually, this one, as you can see, this one, most of the study Okay, they are focusing on the impact of the aquaculture in the still wetland. Okay, good. The objective for my study, and actually the objective for this presentation, actually for this one, the objective to see in terms of physicochemical parameter, okay, to see the spatial and seasonal variation. I focus only for nitrogen and phosphorus. Then I want to know quantify the uptake rate of the nitrogen by phytoplankton and try to evaluate the possible sources of nutrients. Okay, this sampling station, we have 9 sampling stations in the wetland. Okay, cover all major things in terms of the activity, and we have in terms of reference station. That means outside from the wetland, nearby, I mean at the South China Sea, about 200 meters from the shallow, okay, outlet from the wetland. Okay. Most of the main activity actually happen in this particular area. That means from S9, S7, S10 is the aquaculture, okay, activity. We have the blue aquaculture on this side, okay, coming through S1 and S2. We have a small, in terms of small town, Plenary is over here. Okay, method, sensation. Okay, for this one, actually this study is what I did in 2010 actually, this one. We only take for the surface water, and the most important thing, this one, I take the sample during the high water. So I can go to every station, okay, within the wetland. And it's cover from 1 year study, it's cover from the monsoon and non-monsoon season. Okay, this is the method that I'm using. Just to highlight the thing, we filter the thing for the dissolve and the particulate form. I do the inorganic nutrient. I do also for the organic part. I also do for the uptake experiment. Okay, actually the beauty of this study, I try to something like to know how much the nutrient nitrogen is being used for the phytoplankton in this area. I did this one, okay. So I take a sample. I spike with the nitrogen 50N tracer. That means I'm using the nitrate and the ammonia. I put inside here. I leave it for 2 hours inside, and I incubate. Then for 2 hours, then I filter again. Then I take the reading. Okay. Okay. After that, I filter again. Sum the activity. Okay. So for this one, okay, as I will going to present to highlight some few the important things for the what data, the result I got from this study. That means the in terms of spatial distribution plus the seasonal variation. Okay. As you can see here, temperature more or less the same, constant reading for each station. Except for the salinity, as you can see, S1 and S9, because S1 is the fresh water, and member fresh water, and S9 is also the Sungai Ula. Okay, not in terms of the value, not compared to, as you can see, the other station 30, as I said, is a high water condition. That means most of the water during my study actually coming from the salt water. Okay, DO, just to highlight the thing, as you can see, for the DO, this one, I don't want to go detail. As you can see, in terms of the concentration of the DO, more or less, as you can see, rough idea, you can have a low around 4 at sections F7 until F10. Okay, this, as I said before, this is more to the branchish plant culture. For the F1, because as I see, around 4 to 6. Okay, this one is mostly coming from the Plenary town, and some this one, as I said, a big huge of the culture experiment at the blue archipelago. The pH, this one, as you can see, compared to the other station, okay, this one we have around 6 to 4 around this one. It is this is coming from the the branches for pen culture. Okay, this area. Okay, BOD, as I said, low DO just now in this area, you're going to have a high, in terms of population, high BOD in this area, S7 to S10. Okay. Okay, this is the seasonal variation. Salinity, yeah, just keep this one. Not mainly, in terms of to highlight more or less the same. Okay, except for the, as you can see, for the DO. Okay, during the wet season. Okay, this is the wet season. This in terms of the rain amount. This wet season, I can see a low in terms of concentration. Okay, during the wet season, and we suspect this one is coming from the runoff, or from the land into the wetland. Okay, during this time, and they're using the nutrient here. Okay, the pH more or less the same actually. Okay, for the BOD, we have just now, as you can see, a low DO but high BOD. This is what we expect also. Okay. Okay, for the suspended solid, okay, because high duration, okay, you can have a very low in terms of suspended solid to the wet season. Okay, we're going to have for the nitrogen and for first, okay, as you can see here, in terms of nitrate and ammonia, as you can see here, this station, okay, is a low activity, so you can have a low in terms of population for this compound compared to S1 and this one S8, 9, and 10. Okay, very in terms of concentration is high concentration in this area S1, and this particular, as I said, S1 is located at nearby the Plenary. Okay, and we have the nearby the blue archipelago. Okay, this one also we have the huge cage culture over this side. This one you can see ammonium here very high, and at S1 also. Okay, S3, it is our reference station. Okay, very low. Okay, for the PON and DON, as you can see, not many in terms of general trend in terms of their constellation, more or less the same. Okay, this video about my study. I'm using the isotope labeling technique to see the uptake rate of the city wetland. Okay, as you can see, I'm using two types of 15N. I'm using the nitrate and the ammonium, as you can see, very in terms of the uptake rate for the nitrogen. Okay, as you can see here, most of the study also doing found the same thing. Ammonium is being used. Okay, they prefer phytoplankton prefer to have the ammonium for their for their food compared to the NO3. Okay, this one, as you can see, it is about 5 to 7 times compared to ammonium compared to the NO3. Okay, and I compare about the uptake rate for the present study and compared to the other area. Okay, for example, this one like the coastal North Sea, everything here, as you can see, here the uptake rate is very low compared to the other area. Okay, so what happened now? So what happened actually, because this area, they have a very huge in terms of the nutrient concentration compared to city wetland. Okay, that's why they can have a very in terms of high uptake rate of the nitrate and the ammonia. Okay, this is the seasonal variation. As you can see, nitrate and ammonia very in terms of concentration compared to other months, high in terms of the concentration. Okay. Okay, also for DON, PON, okay, this is the trend we got for the wet season, okay, monsoon. Okay, finish about the one, finish about the nitrogen. We're going to see about the phosphorus. We can see here, just to highlight in terms of the station, we have a huge in terms of profession for DIN and DIP at the station X6 until X10. This is we have the branchish cage culture. We have this what the so-called the palm oil plantation at this side. Okay, coming through Sungai Ular F9. For this one, as you can see, no obvious trend in terms of the concentration. For the chlorophyll, as you can see here, most of the chlorophyll, although it is low, but as you can see, higher within the wetland, okay, compared to F3. Okay, this is the reference station, my reference station. Okay, seasonal variation, no obvious trend in terms of compared to just now, nitrate and ammonia. For the DIP and DOP, no obvious trend. Okay.
Sorry, Prof. You still have 3 more minutes.
Okay. Okay, for this one, okay, seasonal variation. Okay, I try to see what is the limiting factor of nutrient. What is it? Is it nitrogen, nitrate, or DIP? Inorganic phosphorus. Okay, I plot a graph. Okay, and we are using the Lexi ratio. Okay, Lexi ratio equal to 50 to evaluate the limiting nutrients. Okay, so from this graph, as you can see, the NFP ratio is about 22. Okay, actually this one, the slope of the graph. Okay. So based on the Lexi ratio, for this wetland, actually P is the limiting nutrient in the city wetland. Okay, that's why I plot a graph and chlorophyll and the DIP. You see a very in term of good correlation between chlorophyll and DIP. Okay, that's okay. Some conclusion for the my study, as you can see, is most of the study in terms of the nutrient is coming from the aquaculture, agriculture, okay, and high during the monsoon season for the nutrient. For the uptake rate, as you can see, is amino is the preferred dominant end form used by the phytoplankton, and the IP is the limiting trait in the city wetland. So just to highlight the thing, it's important to have in terms of long-term study in this wetland, because more of the study in terms of the environment, they just have a short term of study, few months. But for me, it's prefer to have that to have the in term long-term study in the wetland. Okay, by that, so I would like to. Oh, wait sorry. Announcement, the grant that I got from the MOFTI. Okay, so by that one, so thank you.
Thank you, Prof.
Yeah.
Thank you for the inspiring talk, Prof. So, ladies and gentlemen, please feel free to write your question here or use the raise hand button if you wish to ask directly. So, Prof, there's a question from the participants from Munira Abdul Zali.
Yes.
So the participant asked, how did you measure the 15N?
Okay. How I measure? As inside the slide, actually, because in MT INOS, we don't have the facility to analyze for the 15N. So what I did, I sent the sample to Nuclear Malaysia at Bangi. Okay, they have the facility, they have the isotope ratio facility to analyze the 15N. Because actually in terms of the instrument, it costs about 10 to 3 million. Because since they already have the one, I just sent to Nuclear Malaysia.
Okay. Thank you, Prof.
Yeah.
Because I'm the one who asked you.
How are you?
Is it okay to
Yes.
Yeah, because I'm working on the 15 nitrate isotope also. But the nitrate stable isotopes in water sample. Yeah.
Okay, water sample. Okay.
Mm-hmm. And yeah.
Your study area?
My study area is Linggi River.
Linggi.
Yeah. I'm looking at the 15 and also the 15 nitrate and also 18 oxygen nitrate.
Okay. But you can find in nuclear mission, you can contact.
Yeah, I'm from Department of Chemistry. I have the instrument in my lab.
You have the instrument?
Yeah. We have the GCEA IRMS.
There. That's why I'm using the IRMS.
Yeah. We have
Chemistry
Department. Department of Chemistry Malaysia. Tarim Jaya.
Okay, no, you have the instrument.
Yeah. I'm currently doing the research on that and writing my thesis on nitrates.
You're doing the enrichment?
No, I'm working there.
No, I mean, what I'm doing inside my study actually, this is a process of enrichment. I put 10% of the MBA in terms of the profession. Then I increase in terms of the 10% compared to the MBA concentration. They are spiking my sample. That's why somebody they sometimes they just they take the sample to see the signature is sample. What I call the concept I'm using is the enriched concept.
Oh, the enrichment.
Yeah, enrichment concept.
My study is to look the sources of nitrate, whether atmospheric nitrate, whether it can.
Okay. What you're doing actually is not an enrichment.
Yeah. I'm not doing enrichment, but it's also related to my field a bit. Yeah.
You can email me.
Yeah, sure.
Okay, I can give you the contact number. The person that using the person in charge for the IRMS at Nuclear Nation.
Yeah, I think Encik Roslan, right?
Yeah.
We've been friends.
Yeah, Roslan Zairi, yes.
Yeah, because we have IRMS together, so we always do proficiency test together.
Okay. Yeah. Very effective instrument.
Yeah, very expensive, very expensive.
Sorry, Prof. Due to the time limited, we still have a few more questions to ask from the participants. So can Munira contact with you privately?
Okay.
Yeah. So Prof, the second question they asked from Zenfei. He asked, do you have any recent data or predictions of the trend in the year of 2020? Because as human activities decreased this year, he's wondering if the impact caused in the past will have been reduced in this year.
Frankly speaking, I don't have data for the 2020 because this gun that I received actually is from 2010 for the fund. Okay, but when asking about the human activity decrease, I don't think about the human activity decrease in the wetland for this because we have the big in terms of Blue Archipelago is a private company. Okay, then they have something like the export of their thing. The structure to overseas. Okay, I don't think it's a human activity decrease. It seems like it's increasing now. But I don't have data for 2020.
Okay. Prof, there's another question from Azyati. And Azyati is asking, what is your prediction for nutrient concentration in future in fertile wetland?
For me, okay, if you take the sample at the same site condition like myself, okay, during the high water, okay, for me it's going to be increased. As I answered just now about this one, we have a huge private company, okay, and then they stay increasing in terms of their structure inside the drinking water. It's going to be increased.
Oh, okay. Thank you, Prof. Ladies and gentlemen, is there any questions that you like to ask? So thank you, Professor.
Okay, thank you for
all the questions. So thanks again for joining us today.
Okay.
So at last, we wish all of the participants will, open the webcam so that we can have a group photo for this session.
Okay, thank you everybody for joining me in my presentation.